Here we go. Properties of logs. You know, log, it's better than bad, it's good. If you know what that's from, please tell me. I feel like there's less and less students every year that know where that comes from. Anywho, to work with logs, you have to have a pretty good idea of how to write logs in exponential form and in logarithmic form, being able to work back and forth. You need to know a little bit about their bases and how to evaluate them. And yes, your calculator can be useful, so you might want it because I'm going to show you how to use it in just a little bit. So, we have log base b of y is equal to x. To write that in exponential form, it is b raised to the x power is equal to y. So you need to be able to work back and forth. You need to be able to rearrange these when necessary. Okay? So just make sure you understand what you're doing here. So for this one, if we were to write this in log form, it would look like log base 2 of 32 is equal to 5. Okay, if you remember, b to the x is equal to y, gives you bx equals y. So 2 raised to the 5th power is equal to 32. Just make sure you can do it. It's going to be a very good skill to have. So here's another one. Now we have log base 5 of 1 is equal to 0. How would we write that as an exponent? Well, the base becomes the base with the exponent of 0 is equal to 1. Okay, 5 to the 0 equals 1. That's a true statement. So what about this? This is our base. So we have our log, and our base is 1/2. And it's raised to the exponent of -1, which is going to be over here, and 2. So 1/2 to the -1 power is equal to 2, and that follows the same pattern here. Log of base 1/2 of 2 is equal to a -1. So that's kind of giving you an idea of what you're looking for. You need to be able to write that. It's just a little bit of a pattern that has a few properties you need to know. This is the base of the log. This is a base of an exponent. Okay, so logs are actually like the inverse of exponents. So a log without a number over here has a natural base of, or has a base of 10. You don't have to write base 10. Log base 2, this 2 is your base, and ln is actually a base e. ln is another way of saying log base e, but it has its own natural log for the natural base e. So we're going to do some things without a calculator and with a calculator. So to evaluate without a calculator, what you're trying to do is you're trying to think of the base raised to what power will give you the number. So log base 5 of 125, the way you think about it is 5 to what power gives you 125. That's what you need to think about here. And the answer is 3. 5 times 5 is 25 times 5 again is 125. So that's the thought process. 5 raised to what power gives me 125? So the answer to this question is 3. So again, 8 raised to what power gives me 1? 8 raised to what power gives me 1? The answer is 0, because anything raised to the 0 power is going to be 1. Here's another one for you. Think about it. You ask yourself, 9 raised to what power is going to give me 729? Can you think about what that's going to be? Let's try 3. Now I said let's try 3 because 9 to what power, that's pretty big to be able to do in your head sometimes. So why did I say let's guess 3? Well, I have no idea. I just had a hunch, but you can always use your calculator to check. Okay? 1/3 raised to what power is 1/3? The answer is 1. Anything raised to the power of 1 is the same thing. And this last one's a little bit tricky. 4 raised to what power is going to give you 1/2? That one is tricky. 4 raised to what power is going to give you 1/2? You might actually have to think about that and try with your calculator. If you try it a couple of times, here's what we're going to do. 4 raised to what power gives you 1/2? So first of all, look what happened. It got smaller. So from chapter 7, we said 4 raised to a certain power is going to make the number become 2. That would be a 1/2 power. But then how do you get it to flip into a fraction? You need to make it negative. So the answer is actually negative 1/2 because 1/2 is a square root. A square root of 4 is 2, and a negative will flip it. All right, so that's how you do some of these in your head. Now, to do things with a calculator, sometimes you need to have the change of base formula. So when your base is something other than 10, you need to tell your calculator that. So you would use what's known as the change of base formula. So if I was doing log base 3 of 7, 3 raised to no easy number is going to give us 7. So what the calculator needs to do is you need to take the log of 7 and you need to divide that by the log of 3. So you take the log of the number that you're trying to find the log of and you divide it by the log of the base of that log. Okay? So this row right here we're going to evaluate with the calculator. So the ln of 5. That, nothing special, you just type ln 5. Click enter, and you're going to get 1.609. For this section, we're going to round to 3 decimal places unless otherwise stated. Log base 3 of 8. So this is a different base of 10. It's not an ln. So we need to take the log of 8, and we're going to divide that by the log of 3. And then you're going to just click enter and get the value is 1.893. Find the log of the square root of 2. So again, that's log. It has a base of 10 since there's no number there, so we don't need to do any change of base. So we just have to type log of the square root of 2. And that's going to give us 0.151. And the last one is another change of base. So we're going to do log of 1/2. And we're going to divide that by the log of 5. And you're going to get negative 0.431. Okay? So that's how you use your calculator to evaluate logs. And some of those skills and combined with being able to write back and forth are going to be very, very beneficial to you. So, inverses. If you're taking like 2 divided by 2, you get 1. They cancel each other out. So and that would be 2x. So 2 times x divided by 2 would be equal to 1x. And think of some of the other inverses, you know. We have 2x plus 2 minus 2, that's going to cancel those guys out. And divide that by 2, and that's going to cancel those guys out. So we know that multiplying and dividing are, shall we say, opposite operations. Also adding and subtracting. We also know that x squared, square root of that is going to give you x. The square root's going to cancel out the x squared. So how do you cancel logs? Well, that's going to be based on having a base raised to a certain power has to be the exact same. So here we have log base b of b to the x. So when you have a log base b and a b for your base of what you're having for your power, they cancel each other out and you're just left with x. Same with this. If we have the base b raised to a log base b power, they cancel each other out and you're left with x. So in this case, remember, this is an imaginary 10 for that base. So we have 10 raised to a log base 10 of 2. So they are just going to cancel each other out and you're left with 2. Same with this. We have a log base 3 of a base of 3 raised to the 5th power. They cancel each other out and you have 5. This next one, though, that's a little funny because we do not have a 3. So a little bit of groundwork before that happens. Log base 3 of 3 to the 4th power, because remember, 3 squared is 9. So what this is actually is 3 squared raised to the second power is how we rewrote that one. So what does that equal? So now we did our groundwork. Log base 3 cancels out the 3. Bam, bam, see you bye. And you're left with 4. Alright, so that's how we're going to be taking inverses with logs. And we got a couple more to do. So we have 5 raised to the log base 5. Bam, bam, goes away, left with x. We have 8 raised to the log base 8. So 8 log base 8 cancel each other out. Done. You have 3x. And the last one, same kind of properties going here. We have a log base 6 of a base of 6 raised to the 2x. They cancel each other out. Done. You have 2x. So what about this guy? Well, I didn't write the 10, number 1, and this isn't a base of 10, that's 10 squared. So if we were to rewrite this, this would look a little bit like this. Log base 10 of 10 squared x. So that means they're just going to cancel each other out like this. 10 cancels that 10, and we're left with 2x. Alright? So those are inverses. Log base b of b to the x. The b and the log base b will cancel out, and you're just left with x. So now that you know how to do a little bit with logs, here's a problem we did once before. We have 2,000 largemouth bass that are put into a new lake, and the DNR expects them to grow at a rate of 15% per year. Write the equation. Sounds good. 200 is our initial amount. 1 plus our 15% per year raised to the t. So how many in 10 years? So that would just be 200 times 1.15 raised to the 10, and that's just a calculator problem where we just type it in, 200 parentheses 1.15, close your parentheses, raise it to 10 years, click enter, and we got a whole bunch of fish to go catch. We have 809 fish approximately to go catch. So predict how many years till there are 420 bass. Before you knew about logs, this needed to be done with your graphing calculator and graphing it. Now that you know how to use logs, you can actually solve an equation. So now we're just going to say 420 is equal to the original amount of 200 times 1.15 raised to the how many years? We don't know. And now you just solve it. So you're going to divide both sides by the 200. So you're going to take your 420 and divide by 200. If you can't do that in your head, you just use your calculator, but 42 divided by 20 is going to give you your 2.1. So you have 2.1 is equal to 1.15 t. And now you know a little bit about logs. How can we get that 1.15 to go away because it's the base of a power? Well, that's where logs come into play. If we were to take log base 1.15 of both sides, now that you know about the little inverse rule, log base 1.15 of a base of 1.15 are going to cancel each other out, so they just bam bam go away, and you're left with t is equal to log base 1.15 of 2.1. So that's it. T is equal to log of 1.15 of 2.1. Good thing I taught you how to use your calculator to do that, because now you just type it in the calculator. Log 2.1 divided by the log of the base 1.15, and click enter, and you find out that it's approximately 5.3 years till you have 420 bass. Now, of course, you can still use your graphing calculator to find the intersection, but if you don't want to, you can just use logs. That's it for this video. This is Longo, and I'm out. See you, bye.